Hello and greetings. This is question number 6 of October November 2024, A level Maths paper 3, variant 2. In this particular question, we can see that the examiner has given us a linear equation having two coordinate points on ln y and x. The variables x and y satisfies the equation ay equals b raised to power x, where a and b are constants. The graph of ln y against x is a straight line passing through these points. There are 2 points, the coordinates as shown in the diagram. So find the values of a and b. This can be simply solved by taking ln on both sides. So we'll simply write first of all the equation. The equation is a y of b raised to power x, and taking ln on both sides would give us ln of ay problem with the pencil. Let me just ay ln of b raised to power x. So we have this by taking the logarithm rules. We know that if we have product of 2, so this can be written as sum of ln of a plus ln of y ln of b, and before writing that we know that this x would shift as a base, so we'll say that x ln of b. Now what we can do is that I can shift ln of a on the other side, so this would give me ln of y equals x ln b plus ln of a, and I can rewrite this equation as ln of y ln of b as x plus ln of a. Now if I observe closely, this gives us equation of line as y is equal to mx plus c. So this gives us a sense that ln of b would be the gradient, and we already have these 2 points over here by which we can take the gradient. So the gradient, or m, would be equal to, we know that we can take these terms as x1 y1, and this can be taken as x2 y2. So you'll have the gradient as 8.27 minus 2.24 divided by 3.40 minus 0.50. This would give us slope or gradient of this line as, let me just do it directly, so this would be 2.0793. So we know that we already have one m, so m is equal to ln b, so I can just simply write ln b, that if I have ln b equals m, so that is, or m equals to ln b, so you already have the value now at 2.0793. so if you solve ln of b, we know that ln of, if b would be just b, as ln removed you'll get this, and that would be onto the power of e. So that would be 2.0793. If you resolve that, you will get the value of b. So b would turn out to be 7.99. So 7.99, or we can just round it off to 8 also, because one significant figure was required. So we have b, but we don't have a yet. But since we already have the values, so we can just directly take the numbers, like substitution. We can take any number that can be substituted. Let me just resize it so that to make space. Okay, so we already have the equation, so y, we can take any points. We can take the first point, we can take this point, that can be plugged into. So let me just write it. The value of y would be 2.24. So I'll just, instead of that y, I'm going to write 2.24. And we already have the value of p, or we can just directly write ln of p. Ln of p was 2.0793, and ln of a is to be found. And let me just correct it, it was not plus, it was just minus. I have made a mistake over here. Because when it was shifted over here, it would turn out to be negative. So over here, ln of a would be left. Same procedure, I'll just shift ln a over here. So 2.793 minus 2.24, you'll get ln of a as minus 1.20. As we took ln of p, so the same procedure. So you'll directly have the value of a as 0.3. So we have b, that was b was 8, and a is this. So that was our answer. 4-mark question. It was easy natural logs.